All right, so we have seen what an NFT is. Now let's look at the NFT issues. Okay, so actually, when dealing with NFTs, we have observed a lot of problems. But luckily, recently, a paper titled Understanding Security Issues in the NFT Ecosystem listed all of these problems in a very nice way. So I'm actually listing it from that paper. And in the following slides, probably I will give a few examples in terms of statistics. So those numbers will be from that paper. So I really recommend you to read it. So that paper actually categorized the issues in 4 categories. So user authentication, this can be divided into 2 as identity verification and 2-factor authentication. So I will briefly mention all of them in the following slides. The second issue is token minting, the verifiability of token contracts and tampering with token metadata, which is very important. Token listing, the problems are principle of least privilege, invalid catching, seller and collection verification. And for the 4th part, token trading, which are listed as lack of transparency, fairness in bidding, royalty distribution, and market fee evasion. So let's see all of them one by one and start with user authentication. So one problem is the identity verification. So major cryptocurrency exchanges enforce know your customer rules or anti-money laundering, combating the financing of terrorism measures. So for the know your customers rules, if you go to a crypto exchange webpage, you have to prove your identity because they have to know their customers. A few years ago, this wasn't mandatory, so you could simply create an account like as if you're creating a Facebook account. But now, there are some methods like, you're putting your ID next to your face and taking a few selfies from different angles and proving that you are really that person and so on. And for the anti-money laundering case, they actually have list of addresses which actually are known for money laundering or money that are obtained from, for instance, ransomware and so on. So they're listed and they have to check, and they have to work together with countries to see if the money is there's some money laundering is happening or not. But the problem is that NFT marketplaces do not enforce both of them. This is a huge problem. So if somebody buys an NFT or something, maybe they are paying the money from Bitcoins they earn from money laundering and so on, or from their ethereums. And since anybody can download a wallet like a MetaMask and create an account by creating a public and private key pair, the MetaMask actually doesn't know their users because they're simply creating a public-private key pairs. And so we don't know who is actually buying these NFTs and where the money is coming from. And this is a huge problem. And currently, European Union passed a law which actually enforcing these wallets like MetaMask to know their customers. So this is a strange way of approaching. So this law passed recently, and I don't know how they will actually use them. For instance, you can download the MetaMask and create an account by clicking a link. But maybe for the European Union citizens in the future, these wallets will ask them to prove their identity. So maybe in that case, this NFT marketplace sales will be more transparent at the end. So this is a huge issue. And the second issue is the 2-factor authentication. Many NFTMs marketplaces do not support 2-factor authentication, and when it is supported, generally it is not enabled by default. This is also important because some marketplaces actually doesn't ask you to create a password or anything. You simply use your wallet software to log into there. So in that scenario, it is not a problem. But for some marketplaces, when you create an account, you simply choose a password, and actually you give the ownership of your private keys to them. So if somebody guesses your password, they can actually capture your private key And with that, they can actually transfer all of the NFTs or all of your cryptocurrencies to their accounts. So this kind of attacks happened in some of the marketplaces. And after that, they put two-factor authentication and so on. But again, in some of them, this is not enabled by default. Okay, so let's move on to the second issue, token minting. So verifiability of token contracts is very important. And let's talk about what is verifiable. A token contract is considered verifiable if its source code is submitted to Etherscan. So you might say that if a smart contract is written on the blockchain, why we are asking them also to send the source code? The thing is that token contracts are complex. Source code is much easier to audit than bytecode. You cannot simply download this, smart contract from the blockchain and understand what is going on there. It is really hard. So having the source code actually allows us to understand what is really written in that smart contract. Verifiability of external token contracts is crucial as they can be malicious or buggy. So a lot of marketplaces allows other smart contracts. For instance, you minted the NFT by yourself using your smart contract, but you are selling it on the marketplace. So verifiability is important here because maybe your smart contract has a bug or you maliciously put something. So when you sell the NFT, maybe you don't transfer it to the new owner and it stays with you. And many examples of this happen. Some people bought some NFT, but they realized that the NFT are not transferred to them. So it is really important in this scenario. So verifiability is important. As written is here, malicious token contracts may not transfer the NFT after purchase. Many examples are available. Buggy token contracts can burn gas without doing any real work. So if there's a bug in your smart contract, it will burn the gas, but it wouldn't do anything meaningful. So there are some tokens like that, and whatever gas amount you send to it, it doesn't work. You are just burning the gas. Around 28% of the token contracts are closed source. So this means that their source codes are not uploaded, submitted to Etherscan. So you don't know actually what those smart contracts do. So it is a little bit risky when you buy an NFT. Because nobody actually checks the smart contract, right? Because they don't even know there's a smart contract is involved. And in that paper I mentioned, between June and December 2021, OpenSea took down 1,765 closed source tokens, which account for more than $300 million. So it turns out that since OpenSea took down these tokens, this means that there were some malicious or buggy code inside them, but they were sold for more than $300 million. Okay, and this is just checked in for between June and December. So in that paper, what they did was really clever. They constantly crawl these web marketplaces and try to see if they take down anything and so on and so forth. So in the following examples, again, I will be referring to the same paper. So none of the NFT marketplaces that support external token contracts mandate such contracts to be open source. So this is a huge problem. Okay, so you have to be careful if you're buying an NFT from those closed source contracts. So let's look at the second problem in the token minting. So tampering with token metadata. This is important. The metadata of a token holds the pointer to the corresponding asset. We call that this actually where you put a link to the JSON file. So this is inside the metadata URL. So we hope that nobody can tamper it, right? Because it is the link between your token ID and the digital asset itself. Hence, if metadata changes, the token loses its significance because now what you bought is changed, right? Because it links to something different now. The ERC 721 standard for NFTs actually allows for the possibility to change a token's metadata. So most of the marketplaces have the ability to change this metadata when they want. Some of them if you have to look to the smart contracts and see if they can change it or not. Okay, I think Foundation cannot change it. They designed their smart contract in that way, but most of the other famous ones can change it. Changing the metadata violates the expectation of the buyer, right? Because creator owner can change the metadata URL. So now the thing that you bought is mapped to something else. So this is not something you would like. Secondly, creator owner can change the metadata itself, not the URL. So it also changes the thing that you buy. Even if changing metadata is disallowed, like in the case of Foundation at the contract level, creator owner can change it if it is hosted on web domains, right? So if you put the NFT on an HTTP web page, you can simply change the image there. You might delete it, so you might get 404 error if you try to download it. Or maybe in the future you stop paying your hosting fees and somebody buys the domain name and put a different image file there, so the NFT you buy can look different in the future. Okay, so changing the metadata shouldn't be allowed, but even if it is not allowed, you have to store the image in a very secure place and have to kind of be confident that it will stay there for a very long time. But storing a file is a huge problem. It is not only an NFT problem. Like, think about your own files, taking a backup and keeping it for years is a very hard problem. So it shows itself here again. So IPFS is one solution, but again, there are other issues there. So in the same paper, researchers observed that more than 100,000 out of 3 million metadata URLs were changed in 6 months. So this is actually a very huge number, right? So you bought an NFT, it maps to a URL, and in 6 months, the URL is changed, which is not something you would like. So let's move on to the third one, token listing, principle of least privilege. Many NFTMs use a single escrow account during listing. So more than or 100,000s of NFTs can be stolen if the private key of an escrow account leaks. So here what we are trying to say is that when you list your NFT in the marketplace, they actually minted and have the authority is given to a single account. So knowing that single private key will allow you to steal hundreds of thousands of NFTs. So they're actually creating a single point of failure. So all of the NFTs should be used as an escrow accounts. You should use a different account for every different NFT. That is what I'm trying to say. Second problem about listing is invalid catching. So this is very important. Assume that I created and minted an NFT, put it to my web page, to an HTTP web page. Then I listed on a marketplace. So actually what they do is they download the image file, they create a cache of it, probably with a smaller size version, and this is what they list in their web page. So maybe I go to the HTTP and delete that file. But even if that file is deleted, since they keep it in the cache, maybe they're trying to sell something that is no longer available. So this is a huge problem. This is referred to as invalid catching. And the problem is that, again, I'm referring to the same paper, 4 out of 12 million NFTs on OpenSea are actually inaccessible. But 68% of these images are still cached, creating the illusion that the asset linked to the NFT is still alive. So this is a very huge problem, as you can imagine. Third problem is about this listing, seller and collection verification. Buyers have to verify the seller or the collection themselves, because I can claim that a digital asset belongs to me, but probably I may not be the creator, and I still try to sell it, and the marketplace will not do any verification. And as a buyer, all you can do is to check if my social media accounts are really linked to that account and so on, and that's it. So a lot of people bought very expensive NFTs and then realized that they are actually sold by somebody who doesn't really own it or not the creator. Okay. So these are huge problems, as you can imagine. So let's look at the fourth problem, token trading. Lack of transparency. Some NFT marketplaces store sale records and transactions off-chain. So because they, instead of writing all of the sale records or bits and so on the blockchain, which would require cryptocurrencies to pay, they do this off-chain. But this makes it impossible to verify any trades or the ownership history of an NFT. Okay, so you have to look at the marketplace and see how they do things. Fairness in bidding. Again, some NFTMs records bidding off-chain, which can be abused by the NFTM or the users. Maybe you were the higher bidder, but they chose to give it to somebody else. Okay, you never know. Or they may create fake bids, because since it is not written on the blockchain, you don't know they were real, those bids were real, right? Creating an illusion that it is really an expensive NFT, but actually it is not. Royalty distribution and marketplace fee evasion. Okay, so first talk about royalty. So when you create an NFT, either the marketplace or you say choose the royalty fee. For instance, in the physical sale of a art, the creator actually earns the money in the first sale, right? In the second or the third sale, the owner, the creator doesn't earn anything. So here the royalty, actually the percentage that the creator gets in the future sales. So this is the good thing about the NFT. It supports the artist. So the designer, the artist always gets some amount of money in the future sales. And that ratio sometimes determined by the marketplace, like 5% or 15%. So in the second or the following sales, you get that amount of percentage of the sale. And sometimes it is determined in some marketplaces, it is determined by the creator itself. So you can create an NFT and say that royalty fee is, for instance, 5%. Now the problem is that neither royalty nor the marketplace fees are enforced in this standard token contracts. And both can be avoided by a malicious seller. For instance, let's talk about marketplace fee. For instance, when you sell your NFT, marketplace gets some percentage, like 15% or something. So if a buyer wants to pay you 10 Ethereum, sorry, for instance, 100 Ethereum, 15 Ethereum will go to the marketplace, right? But since they want to pay you 100 Ethereum, and at the final stage, when you agree on it at the marketplace, you can contact them and say that, okay, let's not do this on the marketplace since you already agreed to buy that. I will create this NFT and sell it to you outside this marketplace. So this way we can avoid the marketplace fee, right? And royalty fee evasion is something similar because royalty fees are not enforced by the marketplaces. So for instance, you created the NFT and the marketplace tells you that you will get 5% royalty fee in the future sales, so you sell it to somebody else. If that buyer also sells it in the same marketplace, then you get the royalty fee because that marketplace controls this sell operation, right? But if you sell it in a different marketplace, you never get the royalty fee because it is not enforced. So this is one of the problems. Moreover, OpenSea and Rarible, which are one of the biggest marketplaces, allow the creator to modify royalty fee after the sale. This is very strange. For instance, when you sell it, for instance, you may claim that the royalty is 1%, but after somebody buys it, you may increase it to 70%, and that person will never know it. And whenever they make the second sale, they will probably think that they will earn a lot of Ethereum, but they will realize that they actually get a very small percentage of it. So again, let's look at the statistics. Around 9% of OpenSea royalty fees were modified after the first sale. So those people who bought them actually are unaware of this problem. Okay. So maybe they think that the royalty fee is 5%, and when they sell it, they will think that, okay, 5% will go to the creator, 15 will go to the marketplace, and I will get the 80%, right? But maybe royalty fee is now 70%, and they don't know it. So this is a huge problem. So those are the issues. So let's look at a few examples and see what can go wrong. So I really like this example. Actually, I mentioned this in our first day in this course. So Moxie created a very nice NFT. So in this NFT, he linked the NFT to the image file in the web page he hosts, right? So he has the ownership of the HTTP web page. And when you look at this NFT using the OpenSea, you see this image. But if you go to Rarible and look at the same NFT, this is what it looks like. Because since it is stored at the web page, you know, a web page is actually a server, probably running an Apache server. So in that case, since somebody is requesting a JPEG image from you, you can look at the IP address and give the result depending on it. So here the web page understands the OpenSea is requesting the image. So this is what it shows to OpenSea, and this is what it shows the Rarible. And the problem is that when you buy this NFT in your MetaMask wallet, it will look like this. So Moxie here is trying to show you that what you are buying may not be what you are getting. So this is a very nice way of doing it. And the funnier thing is that OpenSea actually wasn't happy with this result. So they removed this NFT from their web page. So they can do that, right? Since it is their own web page. And they removed this. But once they removed this image, in the MetaMask, Moxie couldn't find his NFT. This one also got lost. So this is a very bizarre example. Think about blocking Facebook in Turkey, and everybody in the world cannot visit Facebook, right? This is like this, because you are writing something to blockchain, and it is this NFT, and OpenSea doesn't want people to see it, but when they do it, nobody can see it. So he couldn't understand what is going on. He went to blockchain himself. I also did the same and realized that the NFT is really there. But once OpenSea blocks it, MetaMask, a different company, also blocks it because they are using the same API, same libraries, same source codes. This is the problem. So here we're talking about blockchain and saying that everything is decentralized, but if you are using the same libraries, this means that you are looking at the blockchain from the glasses of somebody else. So they will choose what you want to see. So this is actually one of the future problems that we will see in Web3. Okay, people will not write their own codes. People will not go to the blockchain and find the results. They will ask somebody else, and that somebody will be in control. Okay, that is the huge problem. So let me give you an example about IPFS. So Moxie's example was about HTTP storing. Here, I created a digital art. So it is stored. So in the NFT, you will see this IPFS link to the metadata JSON file. So, okay, so this is the only thing that is stored in the blockchain, by the way. The image is not stored in the blockchain. If you go to this JSON file, you will see that what is mandatory, name and description. These are the things I wrote. And optionally, you can have the image link. Again, this is an IPFS link. As you can see, the image is stored there. So there are a few issues here. Maybe you see it, like here, there are /n. So in HTML, this means new line, right? So when I created the NFT, I press new line. So now it is stored like this. So two things can happen, I can see as an issue. So in the future, if I use this NFT, for instance, in a video game, the description will not think that this is an HTML code. So we will see /n's like here. And the more problematic thing would be that if all of the marketplaces treats the /n's as the new line, this means that they are converting HTML code somehow. So what happens if I inject something here, right? And since most of them are running Apache-like servers, maybe I can write codes like server-side includes, and I can, obtain a lot of things from their memories. So I'm not trying to give ideas to attackers, since there are many attack scenarios already. Just I'm saying that this can happen. So everybody should be careful what they're parsing from the NFT description, because maybe I simply write an HTML code saying that to include, for instance, image search saying that I can put an image here from my web page, and maybe I keep it as a white pixel for a long time, but then I can put a malicious image there and it will appear in all of the marketplaces, right? So marketplaces should be careful. Actually, any software, any web page that takes NFT data from the JSON file should be careful about what they're parsing, right? There can be injection problems. Okay, so here's the image link, right? So you might think that what are these random looking stuff? So I talk you about IPFS, and for every file, it creates a CID, right? So this is actually the CID of that image. So if you go there, from this CID, if you look carefully, actually the CID inspector will provide the SHA-256 hash from here. Okay, so every IPFS address actually includes a SHA-256 hash. And now you can tell me that, okay, you were complaining that the integrity of the image is not provided because you said that hash of the file is not included in the NFT. Now, indirectly from the IPFS link, we can also have the hash of the file, right? The problem is that if you calculate the SHA-256 of this image, its hash is this. So you might ask me, then what is this hash value? Short answer is I don't know. The long answer is that since IPFS divides these images into many pieces and calculate a Merkle DAG, probably this is the hash of the Merkle root. I say probably because there isn't any documentation about it. Okay, I tried to recover it from the source codes, but after a few hours, I said that I have more important things to do in my life. Okay, so IPFS doesn't provide you any integrity indices. It only says that, okay, if you know how to calculate this, again, it is very hard. I couldn't understand from the source code, but at least you can say that, okay, this was the image that was stored at the time. It provides an integrity, but it doesn't provide you the exact SHA-256 of the image file. And again, you might also say that, okay, since every image gets a unique CID, this also means that I cannot put the same file to IPFS system with the two different CIDs, so that I cannot claim that two same images are two different NFTs. But the thing is that whenever you upload a file to IPFS, you actually choose the hash function you want to choose. So in this scenario, Foundation chooses SHA-256, but I can take this same file with this hash, upload it to IPFS, but this time I can choose SHA-512, and so it will get a different CID, but it will be the same file hosted at the IPFS. So some people think that you cannot have duplicate files in the IPFS system, but by changing the hash function, I think you can choose currently 9 different hash functions. So you can get 9 different CIDs, 9 different looking IPFS files, but actually they are the same in the background. Okay, so one problem with the IPFS is this, and again, when you upload the image to IPFS, it is divided into pieces, and each piece are submitted to some node in the network, and after some time, if that piece is not downloaded, that node actually deletes it. So some images from IPFS are lost due to this, but whenever you have the original image, you can upload it again. This way, it becomes accessible again. So a lot of NFTs are currently lost in this way, but this is a problem. Okay, putting it again and making it available is a good thing, but you know, when people talk about NFT, they said that it will be stored in the blockchain, it will be there for hundreds of years, but even after a few weeks later, you realize that the image you bought is no longer stored in the IPFS, right? So these are the downsides of the NFT that we can see.